Alright guys, I'm going to try to finish the videos up today. Okay, couple more types of problems I wanted to take a look at. Okay, like this guy and this guy. Okay, and notice both of them are just parabolas. And you figure if you have a parabola that opens up, okay, or opens down like this, okay, they're always going to pass the horizontal line test. Okay, so when you look at, the horizontal line test, okay, and you ask yourself, okay, are things going to work out? The answer is always going to be yes, okay, with a parabola that opens up or down. Okay, so I'm not going to really spend a lot of time with these problems on the domains and ranges. You saw a lot of that in the other videos this week. Okay, so in this video, we're going to primarily be concerned with parabolas like this. Okay, and I also put this sheet on Google Classroom where notice these first three, okay, are real similar to this guy. And then down here, okay, you have parabolas that have equations that are differences of squares, okay, like this guy right here. So we'll deal with, okay, this guy right here and these three bottom ones in the next video. Okay, so just concerned with this guy and these guys because they can be a handful at times. Okay, so we take a look at this guy, and again, get it out of function notation. So we just write it as y equals x squared, okay, minus x minus 90, okay, and then we switch the x's and y's, okay, so that'll take us to x equals y squared minus y minus 90. Okay, so now we have to solve for y. Okay, so just like the last couple of videos, you say, okay, we'll get all the terms with y together on one side and everything else on the other side. Okay, so we say, okay, well, let's move that minus 90 over so it becomes positive. So we get x plus 90 equals y squared minus y. All right, now here's where the problems develop. In the previous situations, we could factor out y as a GCF, okay, and then isolate it. And if I tried doing that, you say, well, let factor out a y. Well, I'm still left with y minus 1. And so you say, okay, well, let's divide both sides by y minus 1. Well, then you end up with something where y isn't isolated. You end up with x plus 90 over y minus 1 equals y, and the y is not isolated. Okay, so using that method doesn't work. Okay, it does not work at all. Okay, so this is, what makes these problems a little bit tougher than the ones that we've looked at. And you say, okay, well, what do I do here? Okay, well, the only way to isolate y in this situation is to create one term with y. And the only way we can do that is by completing the square. That is it. We've got to form a perfect square trinomial here. Okay, so we have to complete the square. It's the only way to do it. Okay, so you say, okay, well, I have this y squared minus y, okay, and then I have to add something there to create a perfect square trinomial. So over here I have this x plus 90, and whatever I add here, I have to add over here. Okay, and so, what do? Well, remember, going back, we reviewed this at the beginning of the year, and you guys learned it in Algebra 1. You probably saw it in Algebra 2. Okay, you take the linear term, okay, and you take its coefficient, and you can disregard the sign. It doesn't make any difference. Okay, you divide by 2 and square it. So obviously the linear coefficient when I disregard the sign is just 1. So I get 1 divided by 2 and square that. And then I do the same thing over here. 1 divided by 2 and square that. Okay, so on the left-hand side, I get x plus 90 plus 1/4. Okay, and over here, this is a perfect square trinomial, and that factors into y minus 1/2 squared. So now notice I can use a square root to get one term with y. Okay, so over here I just have to add these guys. And let's see, that'd be x plus 90 1/4. And if we take 90 and 1/4 and we change it into an improper fraction, we get 361/4. So I get x plus 361/4 equals y minus 1/2 squared. Okay, so we take the square roots of both sides, and obviously over here this is some number, so every positive number has 2 square roots. Okay? Okay, so we get plus or minus this guy, x plus 361/4 equals y minus 1/2, like that. All right, now, if we look right here, okay, notice we can't have that. Okay, that goes right back to what we've been doing with, functions. You can't have a fraction underneath a radical. Okay, so we have to put that in an acceptable form. Okay, so notice that I will add 1/2 to both sides, and I have plus or minus. Well, we take a look at this. Notice that's like x over 1. Okay, so the least common denominator would be 4, so I'd get 4x over 4 plus 361/4, and that's equal to y. Okay, so let's see, we get y equals, well, that's going to be 1/2 plus or minus, okay, I would have the square root of 4x squared plus, not 4x squared, just 4x, my fault, guys. There's no squared there. Okay, 4x plus 361 all over 4. Okay, and lo and behold, notice this denominator is a perfect square, so I don't have to rationalize. All I have to do is apply the quotient rule. So I get y equals 1/2 plus or minus the square root of 4x plus 361 over the square root of 4, and the square root of 4 is just 2. So I get y equals 1/2 plus or minus the square root of 4x plus 361 all over 2. Okay, so notice I can combine these guys into one big fraction, okay, because they have the same denominator. Not only that, but we have to go back to function notation, and I found the inverse of g, so it would be g inverse of x equals 1 plus or minus the square root of 4x plus 361 all over 2. So you could leave it like that, or okay, you could say g inverse of x is equal to, you could split them up, okay, two different, obviously, functions. So I could say 1 plus the square root of 4x plus 361 over 2, okay, and 1 minus the square root of 4x plus 361 all over 2. Okay, so either way, those two forms of the answers are 100% correct. Okay, and like I said, I'm not going to play around with the domain and range. We did a whole bunch of that in the first 3 videos, okay, to show you what's going on there. Okay, here we're just going to be concerned with, let's just find the function, because that's what you have to do on the quiz on Monday, just find the functions. Okay, all right, so we got that first one out of the way. Okay, I want to take a look at a couple more of these, okay, because I know these usually give some people some problems. Okay, so we take this guy right here, okay, the second one we're going to do, and get rid of the f of x and write it as y equals, okay, x squared plus x minus 12. So again, switch the x's and y's, so this becomes x equals y squared plus y minus 12. And then we isolate the y's. So add 12 to both sides. So we get x plus 12 equals y squared plus y. Okay, and again, I'm going to have to complete the square here. Okay, so y squared plus y, I'm going to have to add something there. And whatever I add to the right-hand side, I got to add to the left-hand side. So x plus 12 plus whatever that is. Okay, so again, disregard the sign here, doesn't really matter. Take the linear coefficient, divide by 2, and then square that. Okay, so I have to add 1/2 squared to both sides. Okay, so on the left-hand side, I have x plus 12 plus 1/4 equals, well, this is a perfect square trinomial, factors into y plus 1/2 squared. Okay, when I add the 12 and 1/4, that's 12 and 1/4, okay, which is 49/4. So I get x plus 49/4 equals y plus 1/2 squared. And then we can take square root of the right-hand side. And when I take square root of the left-hand side, well, that's a number. It's a positive number, so it has 2 square roots. Okay, so let's see. On the right-hand side, we have y plus 1/2. And on the left-hand side, again, I can't leave it in that form. Okay, so that's like x over 1. So the least common denominator is 4. So I get plus or minus the square root of 4x over 4 plus 49 over 4, like that. Okay, so I'm going to subtract 1/2 from both sides. Okay, so I get y equals a negative 1/2 plus or minus. And then if I take these guys and combine them into one big fraction, just like we've been doing, 4x plus 49 over 4. And lo and behold, this guy is a perfect square, so I can just apply the quotient rule, okay, to rationalize things. So we get negative 1/2 plus or minus the square root of the numerator, 4x plus 49, over the square root of the denominator, and the square root of 4 is just 2. So we get y equals negative 1/2 plus or minus the square root of 4x plus 49 all over 2. And then we just combine that, okay, into one fraction, okay? And obviously we want to get out of y equals, okay, go back to function notation, and this is an inverse, okay? So I would say f inverse of x equals negative 1 plus or minus the square root of 4x plus 49 all over 2. Okay, and again, if you want to split it up, okay, f inverse of x equals, well, we could pull those guys apart and we could say negative 1 plus the square root of 4x plus 49 all over 2. And we could say negative 1 minus the square root of 4x plus 49 all over 2. So either one of those forms of the answers is 100% correct. It's just a matter of which one you want to use, okay? All right, so we got that guy out of the way. Let's get the next guy down. Okay, so get rid of the f of x, and so we have y equals x squared minus 5x minus 24. Switch the x's and y's, so we get x equals y squared minus 5y minus 24. Isolate the terms with y, so take the negative 24, move it over, becomes plus, so we get x plus 24 equals y squared minus 5y. And then we have to complete the square. So y squared minus 5y plus something. And then whatever I add to the right side, I got to add to the left side. So we had x plus 24 plus whatever that something is. So again, disregard the sign. we take the linear coefficient 5, we divide by 2, and then we square that. Okay, so I have to add 5/2 squared over here. Okay, so I get x plus 24 plus 25/4 equals, this was a perfect square trinomial, so it would factor into y minus 5/2 squared. Okay, and then we just have to add these two guys together and write it as an improper fraction. So if we go 24 plus 25/4, and then we rewrite it as an improper fraction, I'm getting 121/4. So I get x plus 121, okay, over 4. Now, does that make sense? Let's see. 25/4 is 6 1/4. So if I go 24 plus 6 1/4, I get, yes, that works out. Okay. Equals y minus 5/2 squared. So take the square root of the right-hand side and the left-hand side. Obviously, that's a positive number. So we have 2 square roots. Okay. So again, on the right-hand side, I just get y minus 5/2. And on the left-hand side, again, I can't leave it in that form. I got to combine it into one big fraction. So we find a common denominator, okay, which is 4. So that would be 4x over 4 plus 121/4. Okay, so we combine those guys. Okay, square root of 4x plus 121 all over 4 equals y minus 5/2. And so I'd add 5/2 to both sides. So I get a positive 5/2 plus or minus. And notice that once again, if I use the quotient rule, because that denominator is a perfect square. So if I go the square root of the numerator, 4x plus 121, over the square root of the denominator, 4 is a perfect square, so it rationalizes itself. Okay, so let's see. Okay, we're going to get out of y equals and go back to function notation, and it's an inverse, and I started with f of x, so this is f inverse of x equals, well, combine it all over 2, so I get 5 plus or minus the square root of 4x plus 121 all over 2. Okay, and once again, if you want to split them up, we can go f inverse of x equals, okay, it'd be 5 plus the square root of 4x plus 121 all over 2, and we'd get 5 minus the square root of 4x plus 121 all over 2. Completely up to you whether or not you split them up, okay? All right, so we're good. So we got one more to do, this guy right here, okay? And then we'll shut this video down, okay? So let's see. Okay, same thing, get rid of the f of x, so y equals x squared plus 9x plus 20. Let's see, let's switch the x's and y's first. So x equals y squared plus 9y plus 20. Move the 20 over so it becomes negative, so I get x minus 20. And I know I'm going to have to add something there. Okay, and I'm left with y squared plus 9y. And I know I have to complete the square there. Okay, so disregard the sign, take the linear coefficient, divide by 2, and then square that. Okay, so I got to do the same thing over here. 9 over 2 squared. All right, so we get x minus 20. That would be plus 81/4. Okay, and then this is a perfect square trinomial. We factor that, y plus 9/2 squared. Okay, so I got to add the negative 20 and the 81/4. Okay, negative 20 plus 81/4, and I get 1/4. Okay, so this is just x minus 1/4. All right, we have y plus 9/2 squared. So I take the square root of the right-hand side. The left-hand side is a positive number, so I get plus or minus. Okay, so again, we have to deal with this guy, just like we have on the other ones. So I have this plus or minus square root of, the least common denominator is 4, so x over 1 becomes 4x over 4 minus the 1/4. Over here, I take the square root and I get y plus 9/2. Okay, so I'm gonna have to subtract 9/2 from both sides, so I get y equals a negative 9/2 plus or minus square root of, combine this radicand into one fraction, 4x minus 1 all over 4. Okay, and so we get y equals negative 9/2 plus or minus. Again, that denominator is a perfect square, so we go the square root of the numerator, 4x minus 1, over the square root of the denominator, which is just 2. Okay. All right, so we go back to function notation, and we started with f of x, and so this is an inverse, so this is going to be, okay, f inverse of x, okay, and then I can combine this all into one big fraction, so I'd get negative 9 plus or minus the square root of 4x minus 1 all over 2, okay, and again, just like the other guys, if you want to split it up, okay, into two distinct functions, we can do that. Okay, so we could say negative 9 plus radical 4x minus 1. I think I got a mistake. Over 2. Okay. I think this is plus 1/4. Let me go back and check that. Negative 20 plus 81/4. Yeah, that's positive 1/4. Okay, so this would be plus. This would be plus. This would be plus. I'm glad we saw that. That would be plus, and that would be plus. Okay, don't want to make that sign mistake. Okay, so let's see, getting back here, I did the plus, so I just do the minus. Negative 9 minus the square root of 4x plus 1 all over 2. Okay, so we're in good shape there. And you got to be careful. Obviously, you see, I mean, it's real easy to make little mistakes on these problems. Obviously, I was guilty of it here, made a real bonehead sign mistake. Luckily, something popped into my head, and we went back and corrected that mistake. Okay, so we're in good shape. Okay, so that'll wrap it up for this video.